Hi, in this video we're going to use Pythagoras theorem when we have two triangles with one embedded inside the other. So we can see we've got this outer right angle triangle here, and then we've also got this inner right angle triangle here. And we want to find this length x here. Now, notice that on both triangles, like for example this triangle, we have two of the lengths, and we could use Pythagoras theorem to find the third, so we could find this length. And if we look at the outer triangle, this one, we've got two of the lengths, we've got the 33 and we've got the 16, and we can use Pythagoras theorem to find this other third length of that big triangle. But if we knew that length and we knew that length, we could just subtract them to find this x here. So that's what we're going to do. Let's focus first on the big triangle, this one here. If I draw it out separately to make it clearer. So we've got, this is 33 here, this is 16, and we want to find this top length. Let's just call it y because we've already used x. And then let's use Pythagoras theorem. So remember how Pythagoras theorem works? If you do one of the shorter lengths squared and you add the other shorter length squared, which is 16, it doesn't matter which way the y and the 16 go round, then you get the hypotenuse squared, the length of the hypotenuse squared. This hypotenuse is the longest length, which is opposite the right angle, so it's 33 squared. And then we need to solve for y. So we could subtract the 16 squared from both sides, and then square root both sides to get rid of that squared on the y. So let's do that on our calculator. You get 28.8617. Okay, so we've got that this total length at the top is 28.8617. And as I said, we're now going to focus on this right triangle here, the smaller one. So let's do that. So what are the lengths on it? We've got 16 on the right. This is the purple one. And we've got 21 as the hypotenuse. And this length here is the other one. Let's just call it z, just another letter. And again, use Pythagoras theorem. So if we do one the shorter length squared, z squared, plus the other shorter length squared, that gives you the hypotenuse squared. So z squared, we can subtract the 16 squared, and then we can square root both sides to get rid of the squared on the z. So let's do that on a calculator. Square root of 21 squared minus 16 squared. That is equal to 13.6015. So we can put that on here. We worked out that this length here was 13.6015. And now, can you see, look, if we've got that total length is 28.8617, and you subtract this length here, you'll be left with this x here. So x is just the difference of the two. So x is going to be the total length at the top, which is 28.8617. Subtract the length on the right, which is 13.6015. And if you do that, you get 15.2602. I presume that's in centimetres. So we want the answer to one decimal place. So x we worked out was 15.3 centimetres. And that is the final answer.